Let's get started. So hello, everybody, and welcome to our webinar today on off-the-shelf data quality for Databricks. My name is Vivek. I am one of the co-founders of Lightup, and I have with me Margie, who leads product for us, and she'll help me moderate this session. So this is a second in our series of short webinars. And what we do in these webinars is we focus on one topic as opposed to showing you a deep dive of the entire product and try to go very deep. And so here we'll focus on data quality checks for your Databricks pipeline. Now, since you guys are here, I assume you have some exposure to Databricks. And but just in case you have questions, I'll try to cover the different concepts as we go along. So now Databricks, as you know, is a very, very versatile platform. And people use it for a wide range of use cases. So they use it for running analytical queries. They use it for streaming and batch transformations, and even for ETL orchestration. Now, in order to ensure good data quality coverage across these different design patterns, what you need is a tool that is deeply integrated with Databricks. And that's what we want to show you today in our webinar. Now, let's keep this interactive. So ask questions as you have them. Margie here will bring them up, and I'll take scheduled breaks to ask questions as I go along. So with that, let me start by introducing the team and the company, and then we can go into the product demo. So we are Lightup. We are the data quality and data observability platform for the new data stack for the enterprise. The founding team brings together deep expertise in building large-scale data pipelines, as well as running deep statistical analysis to derive meaning out of data. And those are two key skill sets needed to solve this problem of data quality at scale. We are backed by premier VCs, including Andreessen Horowitz and Spectrum 28. And the rest of the founding team has a lot of experience in building products for the enterprise. The problem that we are focused on is that of hidden data outages. So the reason why we call them hidden is because today your stack has a bunch of different monitoring layers. And yet there are cases where your application monitoring says things look good, your infrastructure monitoring says everything is fine, but yet your data is broken. And now, given how data-driven each of your applications have become, break in data can lead to severe consequences for the business. And we want to be the platform that tells you about these data outages. And just like the other monitoring layers, this is operational in mindset. We want to find the issues as quickly as they happen and help you root cause and then fix it before it affects your downstream applications. We take a fairly broad stroke view of data quality. So if you think of any modern data-driven app, you have a bunch of external and internal data sources feeding data into the app, and then the data makes it out to a bunch of different external and internal destinations. Now, the data is being consumed and used for various use cases, operational and otherwise, at each of these stages. And if the data quality is not intact at any of these stages, you have a problem. Now, we define data quality as anything about the data being wrong. So it could be data availability, where the data is not arriving on time, fresh data is not available, or the data volume is just not right, and you see a drop in data volume. It could be that the data no longer conforms to the agreed upon dimensions. So there could be a change in schema, a column might get dropped, or the data type of a column might change. The data itself could be not valid. So for example, a column that used to register values between 1 and 10, all of a sudden registers value in the range of 100 to 1,000. We want to detect those kinds of issues. There's too many nulls in a column, we want to detect those kinds of issues. Now, why build a new data quality platform? What has changed about this modern data stack? And there are three main things that have happened. So if you look at this Gartner Magic Quadrant for the different data quality solutions, all of these solutions like Informatica, SAP, or Oracle Data Quality, they were very good solutions for the time that they were built for. But now what we've seen is a sheer explosion in the overall volume of data, as well as the cardinality of data. So the data use cases are growing by the day, and now these old solutions don't scale. And I'd like to point out three main scenarios where this happens. The first one is that there is a very high data volume. So now the way these old tools were architected is that they would do import and inspect, where you would do a select star, pull out all the data, run some data quality checks, and then produce results. So this was fine for small data volumes. But now that you're talking about several millions of rows being written to your database, if you start pulling those out, it is very, very expensive on the DB. Instead, what you need is in-place checks, and that's what Lightup implements. So these checks are basically queries that are pushed down to the data source and leverages the scaled warehouse that you have in place to compute these data quality metrics in an efficient way. The other problem is that of high data cardinality. So now think of the sheer number of tables that you have in your data source, thousands of tables, hundreds of columns. And then you have cases where you need a fine-grained resolution. For example, you may want to track sales volume by market. Now, the old approach was to write a handwritten rule, tweak it over time, and then use it to detect data quality issues. That scales for say, a few hundred of rules, right? But the moment you start talking about hundreds of thousands of data assets, what you need is AI-assisted bulk checks that run at a fine resolution that you want. And that's precisely what Lightup does. The third aspect is with this high data volume, people want to consume data as soon as it is available. And so while in the old world, there was this notion of occasional data loads, in the new world, it's slowly moving in the direction of continuously streaming data. And this is something that we'll cover today in the Databricks demo, where we'll show you how to do these checks in a streaming setting. Now, the architecture now would be like you would imagine. Lightup sits as a client to your data warehouse or lake or stream. And instead of pulling out any raw data, it's pulling out results of these aggregate queries to measure different aspects of data quality. At which point Lightup can then run anomaly detection using these AI-assisted rules to be able to find issues in your data, help you correlate them, and then send out alerts on an alerting channel of your choice. We also have integrations with ticketing tools if you wanted to bring together a bunch of these incidents and file tickets. Now, the core workhorse of the platform is this notion of data quality indicators. So just like KPIs would measure the health of your business, a DQI is a SQL query that would measure the health of your data, asset. And there are DQIs that come out of the box with the platform. And these are things like data volume, data nulls, data delay, data conformity, data distribution. And these can be applied to any data asset and have a uniform definition. There is also cases where you have a little bit more complicated need. And here Lightup assists you in using system-built abstractions to create these data quality checks. And finally, if you have cases where you have to write a completely custom check, like, for example, sales volume by market, the example that I talked about, we give you a full custom SQL interface to be able to express these business-specific use cases as well. The second component is that of anomaly detection. So we have done a lot of research in anomaly detection, specifically for these data quality-like symptoms. And we have come up with our own proprietary algorithms to find these issues. These, of course, take care of all seasonality in your data, trends, and are able to now pick out data quality issues for when a data quality metric is not behaving as expected for that time of the day. So with those two coming together, you are able to now create bulk metrics across all of your data assets that are very efficient, and then run anomaly detection on top of it. There are parts of the product that I will not go into, but if you have questions about those, I'm happy to run a custom demo for you or answer your questions offline. But there are features that we have developed over time that make it both plug and play as well as ready for the enterprise. So at Lightup, our core focus is enterprise. And we understand that the requirements can be a bit different from mid-market or lower market. And specifically, I would like to call out 4 things that we do really well. The first is on the InfoSec and security side. And we are SOC 2 Type 2 certified. We try to make sure that we are always ready for these InfoSec conversations, and they go very smoothly, and we're able to deploy at our enterprise customers without a problem. We understand that this being data, you might not want your data to leave your environment. So even though Lightup is only pulling metadata, we can actually deploy in your VPC. And for this, it's we've made it very, very easy to spin this up so that the system comes up within an hour. And you're able to now have a system that calculates the metrics and stores them in your VPC and connects back to a control plane on our side that can manage the system for you. We have made the system extensible by definition. So we understand that in an enterprise, what we want to orchestrate Lightup for is to be able to fit in a wide ecosystem of tools. And so we've made it API first, and you are able to both consume the results that Lightup produces using APIs, as well as configure it using APIs. And the final thing that I want to talk about is query governance. So one thing that we've seen as we are replacing these older incumbents is that the query load is something that people are very careful about. And so even though Lightup queries are very efficient by definition, we do give you full control on making sure that the queries that are run on the Lightup system, for example, don't scan too much data or don't run for too long. So you can put in checks like this, and at that point, DBAs are happy, and you're also happy because Lightup will only run efficient queries and is safe against a user making a mistake. So with that, I'll jump into a description of the demo itself. And today we want to focus on.
I have a question from someone.
Sure.
You mentioned, I think at the beginning, you were talking about design patterns, and the question is about the design patterns. They're asking if you can discuss any design patterns that you've seen and based on best practices for quality.
Got it. So, so let's talk. So today's webinar, for example, focuses on specific design patterns for Databricks. So we've seen three main patterns emerge. And I was just going to talk about those, but generally there is this notion of running scheduled data quality checks. So think of your processing pipeline. You might want to run checks on a schedule at different stages of the pipeline. The other pattern that we've seen emerging is that of streaming. So these are high volume, low latency use cases where people use structured streaming in Databricks, for example, to process this data. And now Lightup can be used to run the checks in the streaming fashion as soon as data is available. And then the third pattern that we've seen is people are starting to use Delta live tables for declarative pipeline definition and for orchestrating their ETL. And in that design pattern, again, we have a solution using Lightup. So let me quickly talk about, go into those design patterns as they pertain to the demo, and they should make themselves clear. And for other applications, I'd be happy to talk about how we can support similar design patterns on say, other warehouses or external orchestration solutions that folks might use. So the first set of checks is SQL-based checks. So if you look at the transformation pipeline here, you see that you go from one Delta table to another, and each of this is a transformation operation. So you go from A to B to C. And Lightup can now run as a client and be able to run data quality queries against each of these tables. And so these SQL queries are both time rate as well as partition aware, so that it's very, very efficient. And as we get these queries using the Databricks SQL APIs, we are able to get the DQIs into the system, pull those into the system, process them, and then generate alerts if we find any incidents. We've seen this pattern to address a wide variety of use cases, right? Going from if you upload data daily, all the way to if you're transforming data every few minutes. This is the most common pattern that we see being used for running actions where you need a human in the loop, and you want to find about data quality issues and then have somebody take an action. The second pattern is that of structured streaming. And in this case, we have the same pipeline, right? You go from table A to table B to table C. But in this case, we are actually inserting, deploying a structured streaming job in the Databricks cluster that would keep calculating these DQIs as data becomes available. And so for this, we use the Spark's ReadStream API to insert streaming DQI computation operators into the cluster. Now, these operators will continuously evaluate DQI updates as new data arrives and send it over to Lightup. So in this case, you don't have to wait for a scheduled job to run. The DQI is calculated as soon as data is available, so gets sent over to Lightup, and at that point, Lightup can run detection on this. And this can support very, very low latency use cases because the Lightup itself will take of the order of less than a second to process and generate alerts of this data.
Hey, Vivek, we have a question here. They're asking the Delta tables A, B, and C. Is this using time travel and change data capture functionality of Databricks?
So we are agnostic to it. So the processing itself, or how what specific notions you use, will have an abstraction in Lightup. So if, for example, if you do want to time travel, or if you want to restore data, we are introducing a notion of revalidating or rerunning the metrics. So while Lightup is only trying to calculate the delta from the last time, if you use specific design patterns in Databricks, we'll have a support for on the Lightup side to be able to get the queries that you want to run. So if you want to run it again on data that was updated or restored, you are able to do that using Lightup. But the underlying functionality of Databricks, we are agnostic to.
Great, thanks, Vivek. Do you want to be in present mode, Vivek?
Sure. I mean, it's just the last slide, and then we'll jump into the product. So for the final one is that of inline checks. So this is where folks want to take closed loop actions. So think of a scenario where you want to run a bunch of checks, and you want to run a set of transformations, tables become available. Now you want to run some checks on it and wait for those data quality checks to pass before you go on and process the data again. And Delta Live Tables is a framework that we're seeing being used a lot. It's getting adopted by more and more customers as we see. And this basically lets you declaratively describe these transformations, and then Databricks takes care of managing all the dependencies and creating these end-to-end pipelines. There's another feature that has come up, which is Databricks Jobs, which lets you orchestrate these tasks in an arbitrary DAG. And so then you're able to string together multiple jobs and create these complex processing pipelines. So if you use these two features, you're able to now use Lightup in an inline fashion. So think of an ETL pipeline that processes a set of tables, and then you can use DLT. You can orchestrate triggered checks. So at this point, Lightup, instead of running on a scheduled mode, is running on a triggered mode. And you're able to run these checks, wait for the results, and based on that, take closed loop actions before you begin to process the rest of the data. So this pattern comes in very useful if, for example, you don't want to process data all the way and then have to repair all the different stages of your pipeline. You want to run checks after each stage and then take closed loop actions. So the actions could range from quarantining bad data or even breaking the pipeline in case of data quality failures. So those are the three scenarios that I'll cover in the demo, but I'll take maybe a minute of break just in case there are questions, and then jump into the product demo.
Actually, we have one other question here. They're asking if we support multiple partition columns.
We do. So let me jump into the product, and I'll show you what all is supported in the product. So basically, the idea is that, especially for a source like Databricks, if you're running SQL queries, you want to make sure that you are partition aware, because otherwise it's very easy to do full table scan or scan more partitions than you need to. And we understand that across different customers, there are different ways in which these partition columns are laid out. And it could be multiple columns, it could be string or numeric columns, it could be columns of the type date. And we try to make sure that the system is robust enough and the interface lets you express each of those. And maybe when I go into the product, I'll show you a couple of those different partition settings.
Cool. And one more question. Are there any monitoring and alerting? Is there a monitoring and alerting support after running queries? And they want to know about integrating with Slack and pager support.
Oh, great. It almost seems like these are cues to the demo. So I'll definitely go into that. And I will basically show you. So yes, you can send out alerts on Slack, PagerDuty. You could, I'll show you some Slack alerts that the system will generate as soon as data gets processed for the streaming case. But yeah, each of those alerts are possible. And I'll go over a couple of them. Okay. Let's jump into the product then. So very quickly, you'll see two sources here, Databricks demo and Databricks demo DLT. I'll first go into demo, show you some of these scheduled SQL-based checks, and then go into streaming and inline checks. So as soon as you configure Databricks as a data source, Lightup has access to all the data assets. And then you're able to turn on profiling, which basically enables a bunch of metrics on each of your data assets. So the metrics could range from table level metrics that, for example, look at the overall schema, which is the list of all columns and the data type of each column. So if the data type of a column changes, or if a column gets added or dropped, you'll find an issue and catch it here. The second table level metric is data delay. So this is the time since the latest event timestamp. And based on your pipeline update, Lightup will learn what the normal data delay looks like. And then if there is a pipeline update that is missed or fresh data is not available, you'll see an incident on data delay. We also track data volume, which is the row count per unit time. And in this case, this is aware of seasonality. So if Tuesdays look different from Saturdays, this will be aware of it and learn that behavior over time, and then able to tell you if data volume does not look healthy for that time of the day. At the column level, you're able to track things like null values. So if, for example, you have null values that are in a certain range, so this is not 0 or 1 checks. Generally, what we've seen is different columns can have different baselines for the percentage of null values. Lightup will learn the distribution and then highlight issues where null values, for example, spike and are higher than normal. We also track the overall numerical distribution for a numerical column, which is the set of percentiles. And what this will catch is the kinds of issues where, for example, the numerical distribution changes. So here, what we're showing is a case where data used to be reported in miles, and all of a sudden it starts getting reported in kilometers. And so you see this 1.6x shift in data, which Lightup is promptly able to catch because it knows what the baseline distribution looks like. For a categorical column, we track the categorical distribution, which is basically the relative frequency of the dominant categories. So in this case, the example is that of a gaming company. You see data from 5 different games coming in, and roughly they have the similar relative frequency. But Lightup will detect an incident when, for example, one of the games starts reporting lower than expected event volume. So in this case, Rummy has a lot lower event volume compared to last day, and Lightup will catch it because it has learned what the distribution looks like. We also track the list of categories. So this is like the table schema. So in this case, for example, if poker or baccarat were to stop reporting values, you would catch it here. And from here, you go into a little bit more system-assisted checks that you can write. So these are expectations for a column that we call conformity checks. So instead of you having to write a SQL query, what Lightup gives you is an interface where you can use simple drag and drop to create checks that somebody would describe in words. So for example, here is a check that checks for a credit card length. And we expect the credit card length to be 16 digits. And if the length is not equal to 16, we want to find out. And so now Lightup is able to understand what percentage of values conform to this criteria. And then if there is a significant change, we are able to generate incidents. And as you can see, you don't have to write a SQL query here. You just can use a drag and drop interface. There's a bunch of different kinds of conformity checks that you can create. You can string them together. You can add where clauses, and you should be able to express most of your use cases. Now, each of these queries runs as a very, very efficient query. And so I wanted to just quickly spend a minute taking a look at one of the queries. So here, if you take a look at this query that we ran from the logs, you'll see that one, we are running aggregate queries against the data source. Two, we are both time range aware. So it's only using the delta. So for example, it's only looking at 1 hour of data for the new hour that came in. And it's also partition aware. So it's only looking for specific partitions in which the data might lie. So that way we don't scan more data than we have to, and the queries always remain very efficient. In terms of setting up the DB, all you need is the basic DB settings. I'll go into the streaming settings a bit later, but basically once you have the workspace URL, ID, path, and token, you are able to give Lightup access. And then enabling these checks is very, very simple. You basically can do bulk operations where you select multiple tables, enable profiling for those, and get these out of the box DQIs that start running and generating these incidents. Now, one more thing that I think came up was the support for partition, right? So let's look at some of these table settings, right? So in Lightup, you're able to specify the partition to use, right? And for example, here is a date hour, which is of the format year, month, date, and hour. We use the 1989C standard for you to be able to specify what your partition looks like. But it might be different than this, right? You might have multiple partitions. And in that case, you can look at, you could select each of those and specify what they look like and what the format is, and be able to deal with whatever your partition representation looks like. And then Lightup keeps these queries very, very efficient.
We have a question, Vivek. The question is, do you support comparing two tables, such as source versus destination, or last week versus this week?
All right, so that would be our next webinar. So we are introducing this notion of reconciliation checks that we're calling data compare, and it should be available in the product in the month of January. And the idea is we support two kinds of data comparisons. The first one is aggregate based. So this is cheaper in execution, where you're able to compare source and target tables for aggregate measures. So for example, all these data quality indicators that you're defining, you can say compare these two tables, and for each column, compare these DQIs. Now Lightup generates this comparison report that notes down the percentage difference for these different DQIs that were measured. So for example, you might compare data volume to data volume, and then data distribution to data distribution, and be able to generate that report. And that gives you a high level idea of whether the two tables are similar or not. And then you're also able to set up alerts the same way. And then if you wanted to do a more deeper check, which is, for example, you have a customer table across two different data sources, and you want to make sure that the two are consistent, that all user IDs exist in both tables, that would be a row by row check. That is a bit more expensive, because in that case, you have to run a row by row comparison and actually pull the data. And data also supports that, and you're able to then generate reports like what are the user IDs missing in the left, or what are the user IDs missing in right, and then be able to understand how well those tables are matched. But both of those features are coming out very, very soon, and in our next webinar will cover those. Okay.
Thank you.
Okay, so then let's move to the streaming scenario, right? So now the scenario is that I want to run some very, very low latency streaming checks. I don't want to run it on a schedule. I want to run it as soon as the data is available. So for that, we require that you provide a few additional settings. So let's take a look at what those settings look like. So in this case, Lightup will be actually inserting or deploying a streaming job. So we need a cluster ID, which is the Spark cluster ID on which we'll run the streaming job. We need an API port, which is the port number to access the Spark API. And we need a DBFS prefix, which is a Databricks file system location where Lightup can store the specifics for the Spark job. So this would be the job code or the stream checkpoint or any such thing. And now it's very, very simple. You can take any metric and convert it into a streaming metric. So I'll go into the specific example a bit later, but first let's look at the metric definition, right? So Lightup has a full custom SQL interface where you're able to specify a metric as you would like, and you're just able to enable streaming. Now, what this does is whatever configuration you put in here, right? For example, here I'm looking at a table. I have a timestamp column. I specify the partition, and I want to run the count aggregation every minute. So what I want to do is as the data comes in, just calculate minute-wise count for each minute window. And you're able to specify a synchronization delay, which specifies you might have data coming out of order as well, right? And you want to make sure you're able to tell the system what part of data to consider stable. So in this case, we are saying any data 2 minutes or older is stable. So now then when you're generating this data, right, you're able to calculate these metrics as soon as data is available, and be able to now detect incidents and generate alerts. So let me zoom a bit into this to show you what's happening. So first thing that you'll notice is it's 10:33 and I have data till 10:31. So that was the last window that closed. So that's how fast the system is running. It's almost instantaneous. It basically, if I go to my Databricks console, what it is doing is it has inserted a Spark streaming job that is actually calculating data as it comes in. This is the DBFS path that I provided. Lightup put a job in there that is actually calculating this data, and it basically keeps updating Lightup. Now the data itself represents a scenario where you have, say, message count on your app, and there could be spikes because bots start hammering your app, or there could be drops because you're dropping some messages. And in each case, you want to be aware as soon as possible. So you don't want to run these checks on a schedule. So now, as soon as you see a drop like this or a spike like this, you want the system to find it and alert you about it. So see this incident that happened at 9 a.m. Based on our settings, the earliest that we would detect is in 2 minutes. And if I look at the Slack alerts that the system generated, you will see that at 9:02, I got a message that my demo Databricks streaming drift detection saw an upper threshold breach. So this is the spike. And when it resolved at 9:30, I will get a message at 9:32. So it's running very, very fast. And you could even look at the Databricks setup. 1 second. Controls are being a bit. Let me share again. Sorry. So if I look at this Databricks log, right, you'll see that the amount of time that it's taking to process is very, very small. And then the rule itself, the monitor itself that runs on top of it also adds a very little latency. So overall, we are able to detect these incidents as soon as they happen. So that's how you would do a streaming setup. And then the second case that I wanted to talk about was that of inline checks. Before I go into that, if there are any questions, I can take some time to answer those.
Nothing at the moment.
Okay, so then why don't we move along and take a look at the inline setup that I talked about. So in this case, what you're doing is another job, right? So use the job orchestration feature to create the pipeline that I showed, right? So just to refresh, you have these DLT pipelines that you create. You can insert Lightup check as a step, in which case it will actually send a request to Lightup when the data is ready, as opposed to checks being run on a schedule and then wait for Lightup's response. So in order to do that, you can just start creating a pipeline like this. So last time I ran this check was at 6 a.m. And let's take a look at what it looked like, right? So I have a pipeline step 1 that runs a bunch of transformations. Some tables become available. Then I call into Lightup and say, Lightup, run your checks, and then wait for those checks to pass before I process the next step. So in this case, the way this looks like is it's basically using the Lightup's API to, first of all, the data source is set up as a triggered data source as opposed to running on schedule. So which is the second data source that I showed you. And this data source now is waiting for a trigger to come in. And that API call gets made into Lightup for a specific source telling us that the table is ready, tables are ready, and then Lightup would start processing them. Then at the end of this pipeline, I have an assertion that there should be no incidents found. So if Lightup returns incidents, I want to break the pipeline. You could use it in a variety of different setups. You could use it to generate alerts. You could use it to actually not stop the pipeline and just continue on, right? And you could also do it based on severity of incidents. So there's a wide variety of configuration possible here. You could tag the different checks and take different kinds of closed loop actions. But in this case, I wanted to stop the pipeline. And what the system told me is I ran a bunch of rules and I found one incident. So now if we go back to Lightup, right? What it's doing is at 6 a.m. when I ran this job, it processed data from the last 12 hours. So if you look at the data here, right, what you'll see is there is data only till this morning when the job was run, right? And most of it would look healthy in the last 12 hours that it got processed, right? So if you look at all of these checks that are running, it was healthy in the last 12 hours. But one of them failed, for which an alert would be sent out. And that was the missing values check. So as you can see in the last 12 hours, there was a spike in missing value for one set of hours. And so that was the one incident that the system detected. And it actually sent it back to Databricks, right? And you're able to stop the run. And once you fix this, you're able to rerun it. And basically that's the pattern that you would use even in more complicated pipelines. Okay, so that's how you would run an inline check using Lightup, using the job orchestration feature. And there are other design patterns as well that you could construct. Basic idea being that you have this notion of an API call being made into Lightup, and checks, instead of running on a schedule, are running based on a trigger. As soon as we get a trigger, we run the check, and the results are available again for consumption on the API. So any setup that uses that, you could have different design patterns within even within Databricks if you wanted to use it.
Someone has a question, Vivek. They're saying that the DLT expectations framework provides some data quality checks, and how does Lightup compare to those?
Okay, so DLT expectations. So actually, Lightup is completely complementary. We talk to Databricks team very frequently, and the idea is DLT expectations is simple row by row assertions that you want to make. So as data comes in, you might want to say certain columns cannot be null, and those are the kinds of checks that you can use. But for anything that is aggregate, inline, and in a statistical check, for that you would come to Lightup. And so there are maybe 2 to 3% use cases where you use row by row checks, which maybe the DLT expectations framework can take care of. But for everything else, for anything that is aggregate and inline and where you need statistical bounds, for that you would use Lightup.
Great, thanks.
Okay. So yeah, that's what I wanted to share in the webinar today. I hope you guys found it useful. If you want to do a deeper dive into any of these design patterns, just feel free to reach out and we'd be happy to set up a custom session to talk about it.
Great. Right. Thanks, everybody. Have a good day.
Yep. Have a great day and happy holidays, guys. Bye.